This is Kelly Hill, technology reporter for RCR Wireless News. I'm here today with Bruce Devine, who is CEO of Signal Hound. Bruce, how are you?
Very good. How are you today, Kelly?
Good, good. I'm glad to have you here. Signal Hound has kind of an interesting backstory, and I'm wondering if you can start us off by telling us a little bit about how the company got started and what you guys do.
You bet. I was in the Air Force for 20 years, and about the 14-year point, I decided that I wanted to do something, have my own business, so do something of the nature of uh, technology that I had done in the Air Force. And so 6 years before I got out of the Air Force, I started my own business because I wanted to have it up and running and work all the kinks out before it was time to retire from the Air Force, so that I could have a viable living when I got done with the Air Force. And so that was a bit tough, having two full-time jobs for 6 years. But when I did that, I began buying used test equipment, and then I would repair it and sell it on the internet. And that was in 1995, actually. So it wasn't the internet wasn't really swinging as good as it is today. So we started with Nuts and Bolts magazine, and it wasn't long before we did make most of our sales on the internet. By 2007, I decided that it was a steadier way to work to fix other people's test equipment instead of having to go to auctions and find the test equipment to fix. So we started doing that, and indeed it was more steady business. And then I hired another technician to do repairs. I put an ad in the paper and got this guy that was local in the area. As it turns out, he was an engineer, and he wanted so badly to leave the company that he was at that he was willing to take a job as a technician, a repair technician. And so he came to us, and when I discovered his talents, I was amazed that an engineer would want to be a technician because they wanted to stay in the local area. Anyways, so he began doing repairs for us, and it didn't take very long before I asked him if he could design a color LCD kit for a line of spectrum analyzers that Agilent builds that the CRTs were going bad on, and there were no more CRTs available. And he said, "Sure, I can do that." So we proceeded to actually design and build that, and we're still selling them today. So those first ones sold in 2006 is when our first LCD kits sold for the 8566 and 8568 spec ends from Hewlett Packard. And then we made another kit for the 8560 series, and that sold good. And so that was working so good that Justin said, "You know, Bruce, I've spent about 1,000 hours personal study on spectrum analyzer architectures. I'd like to build one. I think I can." And so I said, "Great, let's see what we can do." And he built a block diagram on a napkin and got an estimate of how much it would cost in parts. And it was a little too expensive, a little too complicated, and so it wasn't quite yet time. So I said, not yet, but let's look for some better integrated parts. He did. About a year later, he came back with another napkin drawing, and he said, "Here it is, and this is the cost." And it was like, "This is great. It's time. Let's do it." And so we spent about 9 months doing the development of the SA44, and that came out. We did our first sales of the SA44 in early 2010. That was the beginning of Signal Hound. We put the Signal Hound brand on it because I looked around and trying to figure out a brand name to put on our spectrum analyzer, the USB powered spectrum analyzers. And there's the RF Fox, and there's the Signal or Site Master, and there is another one called the RF Hawk. And so we've got animals here, and I'm thinking about what am I going to do for a name for animals. And well, our device can sniff things out, and I thought Hound sounds nice and friendly, and that was the beginning of the name. We looked up the website. It was available, so I bought the website from somebody that had registered it as an investment, and there we go. The Signal Hound brand was born.
Okay, great. So it sounds like this was kind of a gradual process that you guys got familiar with the technology. You had an engineer on staff who had really wanted to do this. So you guys develop and manufacture your own test equipment?
Yeah, so I mean, when we started building the LCD kits, we started our manufacturing process right there because there was a need that I saw, and it's like we can fill this need if Justin can do the engineering. we can do this, and it worked. And so then that's where we went into the Signal Hound, and that worked, and it actually was a better, steadier work than even doing the repairs for other people, because the repairs takes a highly talented person to do efficient repairs. We've got that, but he's only one man. And so we've got the engineer also, and he's only one man, but we can leverage his efforts, because when you manufacture something, he only has to design it once. And so we went in that direction, and we just kept going. So instead of repairs being 100% of the business, it's 20% of the business now, and Signal Hound brand is 80% of the business. And we've done so much with Signal Hound. Excuse me, let me there. I should have put the phone on quiet.
That's all right. So let's talk a little. I'm sorry. Do you want to finish that move toward 20% of the business being repair, and now the rest is your Signal Hound?
Sure. It just, we went into that direction. 80% of the business is Signal Hound sales, and because there's so much of the business is Signal Hound sales, in April of this year, we decided to begin doing business as Signal Hound. So instead of just having the brand name Signal Hound, now we're doing business as Signal Hound, so the company name is Signal Hound. It was a lot less confusing for customers, because they're like, well, we're looking for a Signal Hound, and Test Equipment Plus, who's that? And it was brand confusion. So we consolidated the brand and moved on, and then got some marketing input from marketers, and our marketer. You know what? I'm going to unplug this phone, because I haven't figured out how to make it be quiet. So if I unplug it, it'll be quiet.
Okay. Great. All right. Well, so let's talk a little bit about the equipment that you guys make. You have and how it can be used for network testing. Tell us more about Signal Hound.
All right. So I wrote down a couple notes on the different things that are perfect markets for the Signal Hound's capabilities. And we've got intermittent signals, or interference hunting. That's one of the interesting markets that a lot of people are picking up our Signal Hound for. There's also spectrum monitoring, which is huge. There's a lot of people out there that want to monitor the RF spectrum and want to be able to see if there's certain events occurring and react to that, or use it for information. There's a myriad of reasons that people want to do spectrum monitoring, but for all the people and all the different purposes, that our Signal Hound devices lend themselves wonderfully for that. Spread spectrum measurements. The BB60 is perfect for spread spectrum, because we have up to 27 megahertz of instantaneous bandwidth. And so when we started with our SA series, it only had a 1/4 megahertz of instantaneous bandwidth for IQ streaming. Now that we've got 27 megahertz, we can capture, even a satellite feed, and be able to capture all that data and do whatever kind of measurements that somebody wants to do. They, of course, have to write a program. So we have an API, and they have to write a program to make it do what they want. But the hardware platform is there so that they can do virtually anything that they want, because all the IQ data is there, and complete modulation information has been preserved on that IQ data stream. So that's monitoring. Let's see, there's another application, recording, of course, goes with monitoring. Some people want to record for post-processing. So that IQ data stream can be recorded into the computer for post-processing. There's also just DAS systems. DAS are distributed antenna systems.
Absolutely.
In buildings, and in those DAS systems, I'm discovering that there's a need for a cheaper and more robust solution. I just spent an hour and a half on the phone with a guy yesterday that's in a company that builds DAS systems and does the DAS monitoring to do what things need to be regulated on the DAS systems, and he is just thrilled, and I'm thrilled, and we're about ready to launch into a project to make a better solution for the DAS monitoring. Also, there's ATE. Our equipment, the spectrum analyzers, lend themselves wonderfully for ATE, automated test equipment. So if you have a production line and you've got several different things going on in that production line, instead of spending 10, 20, $30,000 on a spectrum analyzer, you can spend $3,000 on a BB60C spectrum analyzer from us and be able to put it into the assembly line, put a NUC computer with it that has vPro technology, and it's already remotely controllable, and over the Ethernet, data can come back to a central hub, and a person in a manufacturing facility can manage all of the different nodes that they've set up on their manufacturing line, and be able to do wonderful ATE work with it. In addition to that, there's just standard bench troubleshooting that you can do, because it has color persistence, which means that events that happened the most recently are the brightest, and the events that happened further back in the frames start to fade out. And so with that, you can, for example, you can sweep a signal generator, and you can see when it goes past PLL loops. When a PLL loop gets to the edge of a band and it has to switch, you can see a glitch in the signal, and it's amazing. The signal generators that we thought were the pure best signal generators in the world, nothing's pure, because they all have glitches, and as they go along you see those glitches, and then you realize, hey, this is how they work. They're good instruments, but to be aware of that is instructive, because sometimes you can't see it before this, and now that you can see it, you can understand if some test isn't working properly on your production line because you think your generator is sweeping where it is. If that glitch causes a problem, previously you don't see that unless you have a real-time spectrum analyzer. So because we do 80 megasamples a second of sampled IF, we're able to catch virtually everything that's occurring within that instantaneous bandwidth, and it just doesn't get away, and you see a lot more, and you understand a lot more about what your instruments are doing.
Okay, great. Now you mentioned the BB series. You also have an SA series. Can you tell us about some of the differences between those two?
Yeah, the SA series was the first that we came out with, and it has software-based image rejection. The BB60 has hardware-based image rejection. So whenever you mix signals, and internal on a spectrum analyzer architecture, you have to mix signals to get them to the IF frequencies to get it onto the screen. And by the time it gets onto the screen, somebody somewhere in the engineering process has to have considered and done something about the junk that occurs in the mixing process. There's spurious signals, there's mixing signals, there's residual signals from the internal architecture. What do you do about it? Well, there's two major approaches. You can get rid of it in software algorithms, or you can get rid of it with hardware. Well, if you get rid of it with hardware, the filter that passes through in hardware is instantaneous. Nothing gets missed, nothing gets deleted. But in software image rejection, we mix up and we mix down on the signal. So we do high side mixing and low side mixing. We mask those two signals together. And then if the signal occurs in both cases, we consider it a real signal and we let it pass it and display it. If the signal is not present in both cases, then we conclude that it's a spurious or residual signal junk that we need to delete, and it doesn't pass, doesn't get displayed. That takes a finite amount of time. So in about 3 milliseconds, is how it turns out that any event that is shorter in duration than 3 milliseconds, because we use the software image rejection on the SA series, you probably aren't going to see it. It's hit and miss. You might see it. Whereas on the BB60, any event that's even 1 microsecond in duration gets captured and displayed. And so it's just far, far more capable of showing everything that's occurring out there. So with a spread spectrum signal, you'd never be able to see, for example, a Bluetooth signal. You'd never see all the places where it's hopping around and transmitting with the software image rejection. But with the hardware image rejection on the BB series, you can see a beautiful Bluetooth signal on the screen. And so for a lot of people, that's very attractive. As far as I'm aware, the only real-time spectrum analyzer on the market that's less than the $80,000 real-time spectrum analyzers is our BB60C. And so that's, you know, a lot of people are like, no way, you can't do that. Are you sure? And it's like, hey, we have a 30-day money back guarantee. You know, try it. If we're not telling the truth, send it back. You know, but nobody ever sends them back. They fall in love with them.
Well, and they're very compact. I mean, you know, when I think about a signal analyzer, I tend to think of a fairly large, you know, bulky instrument. But you guys have very compact equipment.
Well, yeah, because the whole premise on what we started to do in making USB-powered spectrum analyzers was, look, on the old spectrum analyzers, or even the current spectrum analyzers, traditional, I guess, is the proper word for it. You already have a case that you're paying for in that spectrum analyzer. You have a processor that you're paying for. You have a screen and a keyboard. All of that exists in a computer. Why should the person pay for it twice? And so because the computer has all of that already, all those resources already, is all we need is the RF portion of the spectrum analyzer, and everything else can be done in the computer. Saves a lot of money. And so because of the integration of the chips that are out there now, and software, and how fast the processors are, it has become viable to build spectrum analyzers that have a lot of power with just a very small box. And so that's what we've done.
Okay. Okay. Let's talk maybe a little bit more about the repair area. I just kind of wanted to ask, you know, if there are, you know, trends that you're seeing in terms of, you know, equipment that's in high demand, you know, common issues with test equipment that call for repair. You know, I'm just curious as to what trends you see in that area.
You bet. We've had to focus on just Agilent, HP, now Keysight test equipment to get really good at what we do, because there are literally thousands of models of test equipment out there. And so we found that with one guy, we were getting so busy with all these different models coming in that we either had to get more people to do repairs or limit our repair scope. And so because our business went in the manufacturing direction with repairs, we just limited our scope. So we limited it down to just Agilent equipment that we're going to repair. And that wasn't enough. And so then we limited it down to, okay, we're just going to repair Agilent spectrum analyzers, VNAs, which are vector network analyzers, and signal generators. And that wasn't enough. We were still too busy. And so we further narrowed it down. Okay, we're some of these older models, sorry, we're not gonna repair them. And so what we're seeing is even the older models that are good models, you know, people still want them repaired, but not as much as the newer equipment. So we're getting all the newer equipment in now, and so I don't know if the viewers are familiar with, but I'll just rattle them off. There's PSAs, which are precision spec ends from Agilent. We repair those. We repair the ESAs, which are the economy spec ends. The PSGs, which are the precision signal generator. ESG, which is the economy signal generator lines from Agilent. We also do the PXAs, which are the precision VNAs, or maybe it's, well, I don't. We do all the VNAs, all the late model VNAs that we're getting from Agilent. Also, like the E. Let me make a fool of myself here and see if I can remember the right model. I think it's an E83. You know what? I'm not even going to guess.
Okay.
I can't remember. I stay away from the repair side now. We've got Joe. He's our repair guy, and he does a wonderful job. But yes, what we're seeing is that because we focus on the late model equipment, we've gone through the pain of learning the failures that are in those boxes, and figuring out how to get parts, figuring out how to do component level repairs. And so almost, well, like 99% of the time, when we're sent a piece of equipment, when we accept it in, we're able to repair it. And we're always able to repair it for less than Agilent would have charged, or for less than other shops would have charged. And because of that, even though we've narrowed our scope so tightly, we still have a 6-week backlog. And so,
Okay.
yeah, a lot of people are enjoying the service.
Great. Well, Bruce, thanks so much for talking to us about Signal Hound today. I really appreciate your time. I've been talking with Bruce Devine, who is CEO of Signal Hound, formerly Test Equipment Plus. Bruce, thanks so much.
Thank you very much, Kelly. Have a good day.